Hello and welcome to Math 1324. This is Chapter 5, Section 1, Example 3, I believe. I can count to 3, I promise. Anyway, in this example, it says to find the compound amount for the deposit and the amount of interest earned. $510 at 2.4% compounded semi-annually for 12 years. So this is actually a little bit different from what we've seen before. In the last two examples, we saw simple interest. And now we have compound interest. Now, here's the thing. Compound interest is just repeated application of simple interest. Because what we're going to be doing is we're going to take something and put it into the bank and then just let it earn interest, simple interest. And at the end of that, however long it is, you say, okay, you earned this amount of interest, fantastic, here you go. But what they're going to do at that point is they're going to add that back into your principal. And so your actual principal is going to be going up a little bit. And so in the next period, you're actually earning another amount of simple interest, but on a higher amount of the principal. And so at the end of that one, you actually earned even more interest than you did before, add it to the principal, so it goes up even further. And then that happens again and again and again and again and again. And that is what compound interest is. But we don't have a formula for it yet. Well, you see it in your formula sheet, but let me show you where it comes from. It's really not that hard to figure out, but it is kind of nice to see. So I'm going to start out with basic stuff here. So again, future value is always A. And I'm going to be working with simple interest for now. So at the end of the first period, let's call it year for now. So at the end of the first year, we have the principal plus how much ever interest is earned. But because we're working with simple interest at this point, because it's still the first period, that means that this would be P plus whatever the interest would be for simple interest, which is P, R, and T. But T in this case would be 1 because I'm defining time to be 1 for now. So notice that between these two that there's a common factor of P, and I can factor that out, and I'm left with P times 1 plus R. Good. Now, notice that this is actually very similar to the simple interest formula. The compound, or the future value is this. It's just where T is 1. That's all. And it should be that way. But notice that this is actually what we're going to be saying is the new principal for the next period. So in the second period, let's figure out the future value for that one. So the new principal is the principal, or the balance from the previous period, which was P times 1 plus R, and then plus another interest. But the interest is P times 1 plus R, which is your principal, times your interest rate. But again, notice there's a P times 1 plus R in common with both of those, which is going to give me P times 1 plus R, and what's left over, in this first term there's nothing left over, so we're going to put a 1 plus, and then what's left over here is an R. But notice that we have 1 plus R times 1 plus R, that's 1 plus R squared. So it would give us P times 1 plus R squared. Awesome. And then for the third one, we have A equals P times 1 plus R squared, because that's the principal from the previous period, plus the P times 1 plus R squared times your interest rate. Then notice that those two are in common again, which gives us P times 1 plus R squared. And then what's left over when you factor that out will again be that 1 plus R. But notice that we have 1 plus R squared times 1 plus R. So that's actually going to give us 1 plus R cubed. And then we could just keep going. So after the teeth period, this would become, you just keep going and going and going. I hope that you're seeing that what's happening here is that this is just going to be that number. So this would just be A equals P times 1 plus R to the teeth power. Kind of. But notice that this is just assuming that we are compounding every year. Well, here's the thing. What if we're not compounding every year? What if we're compounding n times a year? Okay, so here, at the end of the first period, R isn't just R, R would be R over N. So you'd have an R over N there. So every one of these would have an R over N. Oops, still just 2. There we go. So R over N, 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 R over N. Awesome. And then we still need an R over N here, but there's also going to be an N here. So at the end of the teeth year, it's going to be this. So the formula that we're actually going to use here is A equals P times 1 plus R over N to the N times T. That's the formula. Now, the reason that there's an N here is because if these are periods, if this is at the end of the teeth year, think of it this way. If we're compounding 12 times a year, at the end of the first year we have 12 compounding events. At the end of the second year we have 24 compounding events. At the end of the third year we'll have 36. In other words, you take the number of compounding events times the number of years, and that will give you the total number of compounding events. Okay, so N times T should be the exponent, and then R over N is right there. Outstanding. And what's great about this is that this is frankly one of the most important formulas for this particular section, because everything just kind of, well, runs off of that. Okay, so we can actually use this formula. Let's go back up here and we see find the compound amount for the deposit and the amount of interest earned. So $510 at 2.4% compounded semi-annually for 12 years. Okay. With compound interest, we have 5 variables: A, P, R, and T. A again stands for the future amount or the compound amount. Okay, so we don't know. We do know that the present value, the amount we have right now, is $510. R is the interest rate, 2.4%, but as a decimal, it'd be 0.024. N is the number of compounding events. I'll come back to that. And T is time in years. It should always be in years. And that's 12. Good. So 12 years. And compounded semi-annually. Semi-annual means twice a year. Quarterly means 4 times a year. Semi-annual and biennial means twice a year. What would 6 times a year be? I'm not sure. Monthly, of course, would be 12 times a year. Weekly is 52 times a year. And daily is, I think my math lab uses 365. If you're in accounting, I believe that's going to be 360, but in my lab math, I do believe it's 365. And it does tell you to use 365. Okay, so N in this case, because it's compounded semi-annual, N is 2. And that's all we need to do. A equals P times 1 plus R over N to the N times T. So A is going to be 510 times 1 plus 0.024 over 2, all to the 2 times 12. And then you just type that in exactly the way it looks. And I'll go ahead and show you how I'm doing that on the calculator, and then I will be right back. Okay, welcome to the calculator. And on here, we need to type this in. So we have 510, parentheses, 1 plus 0.024 divided by 2, close parentheses, caret 12 times 2 times 12 or 12 times 2. Now, if your calculator doesn't have the exponent, make sure, well, at least you're not typing it in the exponent like this, make sure that you use a parentheses around that. Otherwise, it kind of does weird stuff. And there you go. You'd get 679.05. But I do want us to go ahead and talk about something that's very nice on the calculator and get used to this. Okay, so if you go to Apps and then on Finance, click Enter and then TVM Solver. This is going to be important. So it's going to be a little bit weird. And I'm going to write this down as we go on the calculator. And So we have N, I%, PV, PMT, FV, P/Y, C/Y, and then PMT end. Okay. So what we've got here, this capital N represents the total N times T. In other words, it's the total number of compounding events. And in this situation, we had 2 times 12. So on there, you could just type in 2 times 12. And notice if you click enter, it's going to give you 24. That's fantastic. Okay, as for the I%, the I% is in fact the percentage listed in the question. It doesn't want it in decimal format, it wants it in percentage format, which is the reason that it has the percent right there. So in this case, that was 2.4. Okay, so PV stands for present value. And in this question, the amount that you have right now is $510. Except I'm going to make it negative $510. And the reason it needs to be negative, oh yeah, sorry. Negative, not minus. The reason it needs to be negative is because you're giving that money away for 2 years. You don't have it, so it's a negative for you. It's a positive for the bank, but it's negative for you. And that's fine. Nothing wrong with that. I hope that actually helps clear that up. If you're in accounting, that's probably going to be pretty obvious to you because, you know, if you're giving it to someone else, it needs to be a negative for you. It's a positive for them. Okay, as for PMT, PMT just stands for payments. Payments over time is what that's representing. And in this situation, there isn't any because we're not putting any more in the bank. We're not taking anything away from the bank over time. We're just putting money in to begin with at that PV, and so PMT will be 0. Future value is what we want to figure out. We'll come back to that. P/Y and C/Y. Now, these two will always be the same for us. And P/Y and C/Y will be N, basically. So in this case, so notice that if I type in 12 for P/Y, C/Y automatically goes to 12. If I type in 2, which is what we want, P/Y, C/Y also goes to 2 as well. So they're both going to be 2. Now, PMT end or begin. It should always be end unless stated otherwise, and I'll talk about the only times when we get there, if we get there. Okay, now, I said that we want to figure out the future value, the maturity value, the compound amount, basically. To do that, notice that over here on entry, there's a button that says solve, except it's green. That means I need to do alpha enter while my cursor is over FV. And notice that there is a square that's created as a result. And that's going to give me 679.0511299. And that is exactly what we got here, 679.0511299. The exact same thing. So I'm going to go ahead and put a little square right here. All I'm doing is I'm writing down what we saw. Alrighty. The reason that I'm showing you that is because, well, frankly, TVM Solver is not going to be just useful in this section. It will be useful in the next 2 sections. Okay, doing the formula is fine if you want to use the formula, and they're all going to be in the on Blackboard for you to use. But pretty soon it's going to be just easiest for us to just use the TVM Solver. Alrighty, I will go ahead and see you back in the notes. Hello, welcome back to the notes. And in the notes, I need to go ahead and finish this out. So we have 679.0511299. Awesome, that's the future value. And because we're working with money, cut it off at the pennies. So $679.05. That will be the compound amount, aka the future value. And again, we want to figure out the interest earned as well. So for that one, I is just A minus P. So that's going to be 679.05 minus 510. And because I'm not wanting to mess this up, which apparently I just did, so 679.05 minus 510. 169.05. So the amount of interest earned is $169.05. Alrighty, well, here's everything we just did. I'll see you all in the next video. Have fun.